In this video, I will be discussing Webster's method of apportionment. This video is part of a set. It goes along with the videos about Jefferson's method and Adams' method. So if you've already watched those two videos, then a lot of stuff in this video will seem familiar. If you haven't watched those two videos yet, it's okay. This one should still hopefully make some sense. So just to recap here, we are talking about apportionment problems, which are fair division problems where players are entitled to differing percentages of a set of goods, but must receive a whole number of items. And each item is identical and indivisible. The traditional problem in this setting is dividing the seats in the House of Representatives amongst states. So the standard quota is simply the number of seats that a state will receive in the apportionment. And the problem occurs when the standard quotas are not whole numbers. And since a state cannot receive a fractional seat, we have to figure out how to handle that. So this method was proposed by a senator named Daniel Webster in the 1830s. And this method actually has been used on and off from the 1830s until the 1920s. So to use Webster's method, we must first find the standard divisor, which is the total population divided by the total number of seats. So we use the standard divisor to determine the standard quota, and then what we have to do is we give each state their rounded quota. Rounded quota is a new vocabulary word, which I will define in a couple minutes. So we give each state their rounded quota, and if that hands out the total number of seats, we are done. If not, we'll find a modified divisor, lowercase d, use that to find a modified standard quota and thus a modified rounded quota, and then we'll give each state their modified rounded quota, and if that hands out the total number of seats, we are done. Otherwise, we have to try again with a different modified divisor. So as promised, I need to define rounded quota. The rounded quota is just the standard quota rounded to the nearest whole number using the standard rounding rules that you are hopefully familiar with. We look at the tenths place. If that is 5 or higher, we round up. Otherwise, we round down. So let's look at an example here. There will be 14 seats to be apportioned among 3 different states. So I have the populations and the states. The standard divisor, we just take the total population, which is 11,200, divided by 14. So that gives me 800. So now to find the standard quota, I'm going to take the population divided by 800 because 800 is the standard divisor. So here we go. 5,800 divided by 800 is 7.25. And since there is a 2 in the tenths place, and 2 is less than 5, my rounded quota is 7. So on to state B, 3,490 divided by 800 gives me 4.36. And if I take 4.36 and round it to the nearest whole number, I get 4. And then for state C, 1910 divided by 800 is 2.38. And 2.38 rounded to the nearest whole number is 2. So just like always, the standard quota adds to 14. And the rounded quota is going to add to 13. So since we only handed out 13 seats, but we need to hand out 14 seats, the standard divisor will not work. So since we handed out too few seats, that means the standard divisor was too big, because it is backwards from how you would like it to be. If we have too few seats, divisor is too big. So since d equals 800 is too big, we need to try a smaller value for d. So let's try 700. So this time we'll take the population divided by 700 and then round it to the nearest whole number. So here we go. For state A, we get 8.29, which rounds to 8. For state B, we get 4.99, which rounds up to 5. And for state C, we get 2.73, which rounds to 3. And if we add these numbers up, as always, we don't really care what the total is for the modified standard quota. We just care about the rounded quota. So 8 plus 5 plus 3 is 16, which is not 14. So since we handed out 17 seats, but we only need to hand out 14 seats, this divisor will not work. This time, since we've handed out too many seats, that means that the standard divisor is too small. So we need to pick something that is bigger than 700. But 800 was too big. So we need to pick something between 700 and 800. So let's try 750. So same deal, take the population divided by 750 and round it to the nearest whole number. So here we go. For state A, 7.73, that rounds to 8. For state B, we get 4.65, that rounds to 5. And for state C, we get 2.55, that rounds to 3. This still totals up to 16, which is still too much, so 750 is too small. So 800 is too big, 750 is too small, so let's try 775. This time we'll divide everything by 775. So here we go. State A, 7.48, rounds to 7. State B, 4.5, rounds to 5. State C, 2.46, rounds to 2. And 7 plus 5 plus 2 is, at long last, 14. So out of all of my problems that I've done this far, this one I think was the most fiddly, where we had to do the most guess and check. And Webster is like that. Because we are rounding normally, the divisors are a little bit more sensitive. But you just keep playing with it, and eventually you will get it to work.